Hey everyone, welcome back. I'm still working in the Simple Programs project, and I just got a class called App. I want to continue talking about program control, program flow using loops and if statements. And then after this lesson, we'll dive right back into our object oriented programming and look at something super neat that's going to allow us to do some pretty cool stuff. So let's get this out of the way, right? This stuff's important. We got to learn our fundamentals for all kind of programming. We always need to be able to decide if one thing's true, go one way, otherwise another. And we've also got to be able to do things over and over again, or else we're not going to have a very effective program. So I want to talk today about another kind of loop called the while loop. The while loop gives you slightly more control over the over how the program will loop, because with a for loop you have to set up everything ahead of time. With a while loop you can include things like while player is alive, or while not hitting wall, while not hitting paddle, or something like that. We use it a lot with those kind of situations where we're dealing with randomness, input from a user, situations in a game, because we can react and not have to say, all right, you have to do this 10 times. You could say, do this until forever if necessary, till this condition happens. So the while loop is like this. It has a boolean here, and it's a boolean expression. So what's going to happen is we're simply going to continue all of the code in these curly braces while that statement is true. So if I'm going to use a while loop for just a simple kind of printing that we did last time, I need to make a counting variable. So I'll start with x, and I'll say x equals 5. And I can say while x is less than 22, system.out.print line, or let's just print x plus quote, quote. So in this situation here, I'm declaring a variable x, and then I'm going to keep doing this over and over again while x is less than 22. Don't run this yet, though, because this is not going to work very well. What's going to happen is we're going to keep printing 5 over and over again. So one of the things you got to remember about a while loop is in a for loop, we had those 3 parts. We created, we checked, and then we changed. With while loop, we only have one part, and that's the check condition. So you have to create, and you need to do it first. Then you have to check there, and then you have to change it. So I can use x plus plus if I want to increase by 1. X plus equals 2 if I want to increase by 2. X times equals 5 or 4 or whatever I want to do. I can multiply by 5. Whatever I want to do, I'll just simply do an x plus plus just for the demonstration purposes. And I'll make one new instance here, and then I can choose the run method, and as you can see, it prints the numbers 5 through 21. So that's pretty much it, right? That's the while loop. I know if you've got programming experience with other programs, languages, you should be familiar with this idea. The main syntactical difference with Java is that the check condition has to be in parentheses. Please be sure you put a space at the word while. It's just good programming habits to make sure that we don't think that it's a method. All right. Well, I figured that's a pretty short lesson. So maybe we can work on applying these things to do some pretty cool stuff. Earlier, we learned about arrays. Let's see if we can't make our programs really powerful in array processing. So let's write a couple of methods that we can use. So I'm going to write a method called getLargest. Now, all of our methods should be public, or else we can't use them, right? If I made it private, when I right-click on the application, it won't show up on my list of things to do. So we need to make sure that we make it public. Now I'm going to return to the user. I don't want to print. Printing is great for learning, y'all, and it's great for uh, just getting an idea of how things work and debugging. But mainly printing is for debugging only. It's for seeing what's happening behind the scenes. We usually want to return things in methods so that we can I don't know, put them on a graphics window or do something with them. So we want to go back to practicing returning things. So if we're going to take in an array of integers and I want to return the largest number, then we're going to be returning an int. So I'll say get largest. And I'm going to take in an array as a parameter, and I'll just call it array. So we get to review how to make an array. Now, array syntax in Java is a little bit clunky. When you declare an array, you put the square brackets after the type. So it could be an array of objects, like you make a bird or book or student, or in this case a primitive array, int, then the square bracket. Then you give the array a name. I give the name R. I could say nums maybe, or usually I give R. I gave it array actually. So, but when you actually access a value in the array, you need to remember that the first value is 0 and you put the square brackets after the word. So when you create it, you put the square brackets after the type. But when you get a specific value, you put it after the name. Okay? So I'm just going to pull up a quick, picture here that we can draw on so that I can describe what I think is going on here. So an array is like a series of boxes that are connected. Okay? And they're somewhere in the memory. And we're going to take in an array of some unknown size. And we're going to take in this array of some unknown size. It's going to have different numbers on it, like 3, 5, 2, 7, 1, 4. And they could have repeats. And what I want to do is find the biggest number. Well, it's pretty easy for us as humans to look at this and say, okay, 7's the biggest number. Because I can just process them really quickly like that with my eyes. But a computer, it has to only compare two things at once. So we can only compare two things to each other. That's all we can do. We can't just glance at something and see what's the biggest number. So what I want to do is I want to create a variable that starts here. And it will look and see what that number is and see if it's the biggest number that it's seen so far. So right now, the biggest number that we've seen so far is 3, right? Then I want to move this up and look there and see if it's bigger than any number I've seen so far. Well, the biggest number I've seen so far is 3, so that's gone. It's now a 5 because 5 is bigger than 3. All right, I come over here. The biggest number I've seen so far is 5, but now I'm looking at a 2, so I won't change that. Now I'm going to move this up to the 7. That's the biggest number I've seen so far, so I'll make that a 7. And then I'll move this up here, and that's not bigger than 7, and that's not bigger than 7. So the value I'm going to return is 7. A couple key things to take away. One is that we need to use a loop to start the index at the beginning and move it one at a time to the end. When we're done with the loop, we'll simply return what was the biggest number. That biggest number needs to be in a variable. We need to have a variable for this. The other thing about a variable, though, is we have to initialize the variable with a number. So we have to give it a number to start with. Well, if we're looking for the biggest number, we could set the variable to integer dot min value and give it, negative 2 billion something, the smallest number an integer can be. But that's not really preferred. Instead, you should start your variable, just like I did, with the first number in your array being our first guess at what the smallest number is. Then when you loop, you can start on the second number, which is index 1, or you can start back at 0. It's not going to hurt anything. It'll just check that and see that they're the same. Okay, so here's our setup for it. I want to have you try and code this, but in order to do this, you're going to need one little bit of information about an array. So let me show you this. If I make an array like there, Okay, so I made this array A, and then if I just say A here, I can bring it over to my workbench, okay? So I made an array with the curly brackets, and now when I double click on this to inspect it, there are the numbers at bracket 0 is 6, bracket 1 is 3, bracket 2 is 5, bracket 3 is 10. But I want you to look at this one variable called length, and it's the length is the number of them. So that every time you make an array, you automatically get one variable called length, and you call it by saying the name of the array dot length. Okay? So when you loop, you're going to want to start your loop at 0, and you want to loop while you're less than the length, because the last index, this would be index 0, 1, 2, 3, 4, 5. The last index is one less than the dot length, and you get the length by taking the array's name and saying array dot length. So that's going to be new for you, but I want you to give that a try. So pause the video and try and do this. Don't spend too long on it. If you're not able to get it, no big deal. We're going to practice it together, but I just wanted to give you a chance to try it first. Okay, let's see how you did. First thing I'm going to do is I'm going to make a value to hold my largest number that I've seen so far, and I'm going to make it the very first number in my array by saying array bracket 0. I'm now going to make a loop, and I'll say for int I equals 0, I less than array dot length I plus plus. If array bracket I is greater than my largest, then I'm going to make my largest equal to array bracket I. And then when I'm all done with that loop, I'm going to return that largest value. All right, to help us better understand how this method is working, I want to use the debugger tool in BlueJ. So a debugger tool helps you step through a program one by one and see what's happening, and it helps you figure out when something bad is happening. So debuggers are very helpful, but they also are helpful for learning. So I'm going to you have to have it compiled. If yours isn't compiled, you can't do this. It'll be grayed out. But I'm just going to put what are called breakpoints at each one of these. And once you have one, you can just do that. Okay? And I'm going to put it at each one of these places, and it should allow us to kind of look at what's going on and get a better feel for how the algorithm works. All right, so I'll compile that, and what I want to do is I want to make it to where I can kind of see everything that's happening. So I went to view, and I selected show debugger, and let me make an instance, and then I'm going to go ahead and call this method, and let's give it the array 5, 4, remember, got to be in curly braces, 3, 7, 2, 9, 1, I'll give it another 5, why not? So clearly 9's the biggest value, and let's see how this works. So we should see it come up with a debug value there. And the first thing here is that you see we got a local variable because it goes away after this parentheses are gone. And I'm going to pull up that reference to the array, and I just want to leave that there so that we can see what's happening. Okay? So it's stopped here, and I just pressed the step button to make it advance. Okay, here we are. We've declared int largest is now a 5 because that's array bracket 0 is a 5. This I less than array dot length, that's an 8. Okay, array dot length is 8. So we start with I is 0. We're going to run while it's less than 8. Okay, so first we're going to ask the question, if array bracket I is greater than largest. So unfortunately, I don't know how to make it show up here unless we made it like its own separate variable. So you just need to keep track. I is 0 means that we're at that spot right there. So is 5 greater than 5? It's not. So you'll see it's going to skip this stop. It's going to go right back up because I have a stop put in inside the if branch if it takes it. Okay, so now we have I is about to change to a 1. So I is a 1, and we're going to detect if I bracket one, array bracket 1 is bigger than largest. It's not, so you notice it went right back up. We'll do it again. I is now at 2, so now we're at 3. Is 3 bigger than largest? No, it's not. So we're going to continue again, skipping that portion there. Now we go back up to the top again, where I is going to become a 3. Array bracket 3, is that bigger than largest? Well, it is. 7 is bigger than 5. So we should see us enter into the if statement. And we are now going to execute this line of code. Whatever is highlighted in green is what we're about to do. So when I say step now, we're going to see largest is going to get the value at array bracket I, and my I is a 3. So largest will become a 7. And we're going to continue when I is 4. We're going to say nope. Then I is going to become a 5. When I becomes a 5, we have a 9 there, so we should enter the if branch. We should change largest to the value 9, and we'll continue again. Now I is a 6. 1 is not bigger than 9. I becomes a 7. 5 is not bigger than 9. And we're going to go and change I to 8, which closes out that for loop. And notice the I is gone here. My local variables, I no longer have that. It only exists in the for loop. And now I'm ready to return the largest value. And by doing so, it ends the method, and I get the 9 returned to me. So I hope that made a lot of sense to you. We're going to do one more, though. We're going to do another thing that you might want to do with an arrays, and it'll give us an opportunity to kind of talk about a while loop again. So that was a for loop, and we've introduced, which we introduced last lesson. This lesson we introduced a while loop. Let's take a nice way of seeing it. I'm going to say public int get index. So let's say we have an array, okay, that we're looking for, but we want to find a number, okay? So we're going to look for what I call a target. So maybe I'm using like maybe parallel arrays or something like that. I've got some important information that's at a specific index in the array, and I'm looking for it, and I want to return that index. So let's go back to our picture here. This time, I've got this array again. Let's just stick with what we made. But we're not only sending this array here, but we're also going to be talking about a specific target. So let's say I say my target is 2. Well, then what I want this program to do is I want it to search, and I want it to start here and see if that value is 2. And if it is, it'll return the index. Well, it's not. So we'll go over here and see if that value is 2 at index 1. It's not. So we go over here. Is that value 2? It is. So it will return the index 2. It's kind of ironic that the target is the same as the index. It doesn't usually happen, but that's what it would return. And it would return right then. It doesn't have to continue for the entire rest of the array. And in fact, I don't want it to, because if it finds another 2, then it would, I want the first index of it occurring. So what would we do if we kept going and we never found the 2? Well, at some point we'd have to stop. And what you do is you return -1 to indicate that you never found it. Since -1 is not an allowed index, it's a signal to the user that, hey, you did not have this value in the array. So let me do this one with you. Watch how I do this. If we're using a while loop, we need to make a variable. I'll say int index, and I'm going to start it at 0. And I'll say while array. So while index is less than array dot length, okay, and I'll say if array bracket index is equal to equal signs to my target, then I have found the correct index, and I'm going to return that index. Else, what should I do? Well, if else meaning that wasn't the right index, so let's try the next one. And so there, I just moved the index forward. Okay, let's, oh, we need to return something though. Okay, so we return index if we found it. I want to point that out. What happens when that happens? That array will processing will shut down. It will not continue looping, because once you return out of a method, and you'll see this when you run the debugger, it's no longer there. It's no longer in the method. But I do need to return something because I promised here to return something. So I'm getting an error saying missing return statement. But remember, we said if we don't find it, we'll return -1. So if we go through the entire array and we never find it, we'll return -1. All right, I want to run the debugger, and I want to do it twice before we close this out. Once where we find it and once where we don't. So let's set a breakpoint. We can just set it. Each one of these is fine. I don't think I can put one at an else, can I? Yeah, I can. All right, and then here we go. All right, cool. So now let's go and let's give it a try. I'm going to make an instance of this. Make sure you've got your debugger on. Let's run the get index, and let's give it an array of some random numbers. Try not to keep it in too much. 7, 8, 1. Okay. So I'm going to look for the number 7, and it should return 0, 1, 2, 3. It should return a 4. Okay? So we start. Here comes our debugger that we know and love now. Let's pull up this. I want to make it to where I can see, though, a little bit better. All right, let's pull up this array reference here so we have that as well. So I've got my method that I'm stepping through. Remember, the line in green is the one we're about to execute when I say step. And this is my array, and we'll have to keep track of what our index is. Okay, so we got a couple different variables here. We have an array, we have a target, and we have an index of 0. If array bracket index, which for index 0 is equal to target, is that true? Is 5 equal to the target 7? It is not. So I skip to the else. Watch the index increase to 1, and we're back at here. Is that a true statement? Yes, it's less than the array.length. So we continue. We check, is 4 now equal to 7? It is not. We increase the index to 2. Now we're here. We check, is 2 equal to target? It is not. So we increase the index to 3. Is that true? Is 3 less than array.length? It is. So we now check our array bracket 3. Is that equal to target? It is not. So I increase the index. All right. Now we got index of 4. Is 4 less than the array.length? The array.length is 7. It's right here in the array. Okay, so I'm good. And now, is the value at index 4 equal to the target? Array bracket 4 is 7. That is the target. So now I'm going to return the index. And notice the method's done. We're no longer debugging it or anything because it returned. And we got a 4, which is the index that we wanted. All right, let's do that again. This time, let's give it a target that it's not going to find, okay? And I'm going to give it a target of 12. So we should see it go through the entire array this time without ever finding the target 12. And remember, we're going to, and I'll highlight it as we go, but we're going to need to make an index value, and that index value, we're going to check each time if it's less than the array.length, which in this case is 6. So 6 is the value here. It doesn't equal 12. Push up the index. Is 1 the index? The index, is it less than the array.length 6? 1 is less than 6. I continue. All right. Nope. I push it up. Well, anyway, this is going to keep going for a while, okay? But I do want to point something out when we get to, let's do 5. Okay, now we're in an index of 5. This is our last index. So it's going to check 5 less than array.length. Array.length is 6. That's true. So we enter the while loop. if array bracket index, so array bracket 5, does 9 equal the target? It doesn't. I'm going to push the index up now to 6. Watch what happens here. This is no longer true. 6 is not less than 6. I go down here. I return -1. That tells me that what I was looking for wasn't there. Okay, so some pretty cool algorithms and stuff. I hope you enjoyed that. Searches for biggest values, searches for index. That kind of stuff's super important. And also, hopefully, I understood loops a little bit better. So I think that's enough about loops. Next lesson, we're going to learn about subclassing, and then we're going to go right into making big projects with the Greenfoot application. I'm so excited about it. And so until I see you again, take care.